And it is therefore now, after we have seen so far, we have said atom is made up of the other smaller substance. It is why now we call them subatomic particles. These are called subatomic particles. If this is so, now we have to discuss about subatomic particles. So if now we have seen atom may be divided into simpler substances called protons, neutrons, and electrons. Now we want to know what those subatomic particles and where are they located and how do they behave like. Then subatomic particles. In 19th century, Sir j.j.thomson carried out an experiment. In 19th century, Sir j.j.thomson carried out experiments and described an atom as a sphere of positive charge with negative particles called electrons spread about the sphere. According to j.j.thomson, he said, an atom is a sphere-like structure, which is made up of the positive free particles called protons. And this electron spread about the sphere. So according to j.j.thomson, he said, an atom is like a sphere. It's a sphere-like structure, which is made up of the positively charged, and there are electrons split on that positive. That was according to him. So in 19th century, Sir j.j.thomson carried out experiments and described an atom as a sphere of positive charge with a negative particle called the electron. Negative particles are called electrons. Spread about the sphere. Here it is. So this is a sphere, according to JJ. This is a positive particle. But these are electrons, negatively charged particles, spread about the sphere. That was according to j.j.thomson. And he called this model as Prampadin model. This model of the atom was called the Prampadin model. If that is the Prampadin model, that is, it is a sphere with positive charge, but there are electrons that are negatively charged particles that spread about the sphere. They spread about the sphere. If now this is the sphere, now there are electrons which are negatively charged particles spread about the sphere. And it is called the Prampadin model. If this was correct, another scientist reasons, is it true that an atom is like a sphere? If another scientist reasons, is it true that the atom is a sphere with positive charge and negatively charged particles spread about the sphere? That is, however, now scientists called Ernest Rutherford. Ernest Rutherford reasons that if Thomson's model was correct, then the mass of the atom will be split throughout the atom. Ernest Rutherford reasons and asks, if this is correct, now we expect the mass of an atom would you split? You'd find the mass of an atom here, or here, or here, or here, or wherever. Then Ernest Rutherford carried an experiment. Did an experiment. And he found that the mass of an atom was concentrated at at the central core, at its central core. That was another problem. Because the problem of j.j.thomson, it was that if this is the structure of an atom, so we expect the mass of an atom would split throughout the atom. Means that it would be possible to get an atom here. So we expected to find the mass of an atom here, or here, or here, or here, or here. Means the mass of an atom would split throughout the atom. Then Ernest carried an experiment and discovered the mass of an atom was said to be concentrated at its central core, and that central core was called the nucleus. This is what I've said here. Then he carried out the experiment and discovered that most of the mass of an atom is concentrated at the central core, called the nucleus of the atom. And he said and discovered within the nucleus there are positively charged particles called protons. The mass of an atom, according to Rutherford and according to his experiment he did, the mass of an atom was concentrated to its central core, and that central core was called what? Nucleus. And inside the nucleus, he discovered there are positively charged particles called the protons. Yeah. So we have seen negatively charged particles that are there, which are called electrons. And also, we have seen positively charged particles that are there, which are called the protons. Then, according to the Rutherford, he summarized points. Where these protons, he said protons are there, and the electrons are there. But the protons, he said, are located in the nucleus. Then, according to Rutherford, the following conclusions were drawn from the experiments he did. As you may see, he said there are protons and the electrons. But according to him, he said, and he defines, till today we define as it is. Protons are positively charged particles of an atom. There are positively charged particles of an atom. Those are called protons. In China. And these protons are located in the nucleus, means they are found in the nucleus. If now you are looking for the protons, you have to go in the nucleus. If you want it in the nucleus, you won't find what we call it the protons. They are called positively charged particles of an atom, and they are found in the nucleus. Most of the mass of the atom is located in the nucleus. According to Rutherford, he did an experiment and found that most of the mass of the atom is found in the nucleus. Means the mass of an atom is concentrated at its central core, called the nucleus. And then he said, the nucleus has relatively smaller volume. Means nucleus, it is volume. The volume of the nucleus is very, 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 very small compared to the volume of the whole atom. That is what he said. The nucleus has relatively smaller volume compared to the whole atom. So the volume of the nucleus is very small compared to the volume of the whole atom. That was according to Rutherford. And it was verified that using the experimental evidence. And until today, it is how now we can define what we call it protons. So till today, when we talk about protons, we mean these are positively charged particles which are found in the nucleus. And the mass of an atom is always said to be concentrated at its central core called nucleus. And it is where now you find what we call them protons. Then, according to Rutherford, he said, electrons are negatively charged particles of an atom. According to j.j.thomson, it was true that atom is made up of protons and positive and what? And negative. Means protons and electrons. But it is not true that electrons split out the sphere. If that would be possible, means the mass of the atom would split throughout the atom. But according to Rutherford, he did the experiment and found that the mass of an atom was said to be concentrated at its central core called nucleus. So he came out with the conclusions. Electrons are negatively charged particles of an atom. They move around the nucleus. They move around the nucleus. They move around the nucleus. Mean they revolve around the nucleus. Electrons are there, but they move or revolve around the nucleus. And they do not revolve randomly. Go this, go this, go this. No. They move through their orbit, their only path, their only way, called orbit. So they do not move randomly, but they move in their specific way called orbit. And those orbits are called shells or energy level. It is something that we are going to discuss. So according to Rutherford's conclusions, he said, electrons are negatively charged particles, but they revolve around the nucleus in their orbit, in their special way, in their special specific way, called the orbit. So they move around the nucleus in the orbit. Orbit is the path that is taken by the electrons when they are moving around the nucleus. If that's the case, electrons therefore have very small masses compared to the protons. As we have seen, the mass of an atom is said to be concentrated at the nucleus. So this electron won't have more mass than protons. Because the mass of an atom is concentrated at its central core. And that's why we say electrons have very small masses compared to the protons. And he called this model planetary model. Means the nucleus, you see here, which inside there are protons. And outside the nucleus, we have electron moving around it. So this is just like a planetary model. As the planet move, according to geography, planets move around the sun. Is this all? You learned about it. Also, this electron move like planets around the nucleus. And that's why he called the planetary mode. The planetary mode of the atom. So means there was the nucleus made of protons. But outside the nucleus, we have electrons that are moving around the nucleus. So this is the nucleus. And these are electrons. So outside the nucleus, we have these electrons that are moving around. And they do not, as I said, not this point. They do not move as random. Other going this way, other going. No, they move in a specific way called orbitals. And these orbitals, in scientific language, we call them shells or energy level. So this was according to Rutherford. So the first one who started it about subatomic particles how do they behave, and where are they located was j.j.thomson. But j.j.thomson was reasoned by Rutherford. Means Rutherford tried him. And then Rutherford came to conclusion about this one. Then, in the nucleus, there is something that was discovered by Chadwick scientist. A scientist called what? Chadwick. According to Rutherford, he said an atom is made up of protons and neutrons protons and electrons only. According to Rutherford. Then another scientist called Chadwick reasons about the structure of Rutherford. How does it? Let us see. This is what we have said, according to Rutherford, that an atom is made up of protons which are found in the nucleus, are called positively charged particles. And we have to explain more about it. And then, outside the nucleus, we have electrons. Those are the negatively charged particles. They move or revolve around the nucleus in their orbit. Then, in 1934, another scientist called Chadwick established that there were neutrons that also formed part of the nucleus. So, in this year, another scientist called Chadwick established something and said, inside the nucleus, it is not all about protons. We have other things which are called what? Neutrons. So in 1934, Chadwick and other scientists established that there were neutrons that also formed the part of the nucleus. These particles had the same mass as the protons, but no charge. According to Chadwick, he discovered that inside the nucleus, there were protons and neutrons. But neutrons and protons have nearly the same mass. But what it comes are different that neutron has no charge, means neutral. And it is therefore the following properties of the neutrons were discovered. One, they have no charge, that is neutral. If it has no charge, that is neutral. Example, this is sodium, and this is sodium once again. These have got charge, these have got no charge. This is neutral, and this is ion. So, they have no charge. According to Chadwick, one of the properties of the neutron, they have no charge. They are a neutral. So we had from here, we had the negatively charged particles that revolve around the nucleus. And also, we had protons, which are positively charged particles, and are found in the nucleus. But inside the nucleus also, Chadwick discovered that there were neutrons, which have no charge. So one of the properties, they have no charge. But also they are located in the nucleus of the atom. They have nearly the same mass as the corresponding protons. Means the mass of the protons and also the mass of the protons and neutrons are the same. They are near the same mass. But also they have mass nearly 1,840 times the mass of an electron. Means if now you are having the mass of an electron, in order for you to get the mass of neutron, you have to multiply it by 1,840 to get the mass of proton or neutron. So if now you are looking for the mass of proton or neutron, you have to take the mass of electron, you multiply it by 18-fold to get the mass of proton or neutron. And that's the meaning of this statement. Means they have mass nearly 18-fold times the mass of electron. means the mass of neutron is equal to 18 times the mass of electron. So mathematically, in order for you to get the mass of proton, you have to multiply this mass of electron times this number. And it is therefore a simplified mode of an atom. Here it is. Inside the nucleus, we have protons and neutrons. Remember that point. Inside the nucleus, we have protons and neutrons. And outside the nucleus, we are having electrons that move around the nucleus in their orbit. I've said in their orbit. They do not move randomly. They do not move randomly. They have that specific way on where now they move around the nucleus. And that way is called orbit. This orbit of electrons, we call it shell. We have something to discuss. Therefore, this is the simplified mode of an atom. Now, this is how an atom is made. So, an atom is made up of 3 subatomic particles. We have protons, we have neutrons, and we have electrons. And every one of them have that it is specific characteristics or properties. Now, the way they behave, we have explained. The position of those subatomic particles, we have explained. Therefore, these protons and neutrons, protons and neutrons are called nucleons. They are called nucleons. Why are they called nucleons? Because they are found in the nucleus. So whenever you're talking about neutrons and protons, in the one word, we call them what? Nucleons. And the reason why are they called nucleons, I've said, because they are found in the nucleus. Now, a simplified mode of an atom, a simplified mode of the atom, here it is. Inside the nucleus, we have protons and neutrons. And what is interesting again here, if now this has no charge, in the nucleus, we have protons, which are positively charged particles. So, according to the law of charges, we expected the repulsion between those positively charged particles. So, we expected we have no nucleus. And that is what I've written here. Not, with the exception of hydrogen, except hydrogen, the nuclei of all atoms contain 2 or more positively charged protons. Now means, in the nucleus, we have more than 1 protons, which are positively charged particles, and they stay together. But according to the principle of charges means, if we have like charges at the same place, they repel each other. But if we have unlike charges at the same place, they attract each other. So we didn't expect this nucleus to be formed here, because it was having something what we call protons, which are unlike charges. So we expected repulsion of the nucleus. So if repulsion would happen here, breaking down of the nucleus. But this is what I've written here. With the exception of hydrogen, the nuclei of all atoms contain 2 or more positively charged protons. According to the law of charges, like charges repel, while unlike charges attract. So the electric force of repulsion between the like charged protons should cause the nucleus to break apart. Should cause the nucleus to break apart. But this it does not. Why does not? Due to the strong force that is holding the protons together and the nucleus together. And that energy is called binding energy. So it is possible to have nucleus because of binding energy. In absence of binding energy, no nucleus. Protons would repel, and form repulsion. And that is why I've written that electric force of repulsion between the like-charged protons should cause the nucleus to break apart. But it does not, due to the force called the strong force that is opposes and overcomes the force of repulsion. So binding energy, it opposes and overcomes what we call it the force of repulsion between the protons and hold together the nucleus. So the nucleus is held together by the binding energy, which is there to oppose and overcomes the repulsion force between the protons. That makes it easy for the nucleus to be formed. Now, nucleus is possible because of the binding energy. And when the binding energy is strong enough to hold the nucleus, we form what we call the stable atom. Now we say strong binding energy. Strong binding energy forms a stable atom. Means if now the binding energy is strong enough to hold the nucleus together, the atom is stable. But some of the elements we find this binding energy is not strong enough to hold the nucleus. Those atoms are called unstable atom. Unstable atom. So means that the binding energy is not enough to hold the nucleus together. So if now you find the binding energy is not strong enough to hold the nucleus together, that atom is called unstable. But if now you find the binding energy is strong enough to hold the nucleus together, that atom is called stable. So we have unstable atom and stable atom. These unstable atoms are the ones that undergo radioactivity, which is not a part of this one. So if now you get so far in physics, you learn about the unstable atom, which undergo radioactivity. Stable atom cannot be undergo radioactivity. That's something impossible. You got me? So this is all about the structure of the atom. Why is it possible for the nucleus to be formed? I've said. How are they arranged? I've said. How do they behave? I've said. So it is all about the structure of the atom. The structure of the atom. So we are still moving.